The human fingerprint on global warming was likely evident in Earth's atmosphere far earlier than previously thought, even before the invention of modern cars, a new study says. Using a combination of scientific theory, modern observations, and multiple, sophisticated computer models, researchers found a clear signal of human-caused climate change was likely discernible with high confidence as early as 1885, just before the advent of gas-powered cars, but after the dawn of the Industrial Revolution. The findings, detailed in a paper published Monday in the journal Proceedings of the National Academy of Sciences, raise the likelihood that humanity has been remaking the planet's climate in a detectable way for longer than previously believed, and highlight the importance of tracking changes in the upper atmosphere. Scientists had begun to record surface temperature observations by the mid-19th century. The start date for a detectable human signal in surface temperatures has generally been thought to be in the early to mid-20th century, though other parts of the climate system showed signs of change at different times. For this study, the veteran climate researchers posed the question, with the observational tools of today, when is the earliest that the signs of human-caused climate change would have been detectable in the atmosphere? The study looked specifically at signals in the stratosphere, the second level of the atmosphere. Most weather occurs in the lowest level, the troposphere. While greenhouse gas emissions warm the lower atmosphere, they exert the opposite effect on the stratosphere, particularly its upper regions. Researchers use this knowledge to examine climate models looking back in time for signs of these effects. The findings surprised lead author Ben Santer and co-author Susan Solomon, who did not expect to find such a clear human signal in the upper atmosphere so early in the climate record.
It was surprising, really surprising to me, the answer that we could have identified with high confidence a human-caused stratospheric cooling signal within 25 years of the start of monitoring, if we had back then in 1860 the measuring capability that we have today.
Santer, of the Woods Hole Oceanographic Institution, said, "The signal of climate change was detectable in the 19th century atmosphere after just a 10 parts per million increase in carbon dioxide concentrations in the 40 years between 1860 and 1899. For comparison, planet-warming carbon dioxide levels skyrocketed by about 50 parts per million between 2000 and 2025, Santer said. Overall, carbon dioxide levels in the atmosphere have increased by about 140 parts per million since the initially detectable point the scientists pinpointed.
The results show it would have been detectable very quickly,"
said Gabby Hegerl of the University of Edinburgh, who was not involved with the new paper.
"This highlights the strong influence that greenhouse gas increases have on the upper atmosphere compared to the variability there."
Andrea Steiner, a climate scientist at the Wegener Center for Climate and Global Change at the University of Graz in Austria, told CNN the study shows human-caused climate change can be detected earlier in the atmosphere than at the surface.
This confirms that temperature change signals of the atmosphere are effective not only for detection, but also as early indicators of the success of climate mitigation efforts,
she said. Steiner was not involved in the new study. Both Santer and Solomon emphasized the results show the importance of continuing to closely monitor the upper atmosphere. That message comes at a time of steep scientific budget cuts, when crucial climate satellites and research programs are being targeted. This is particularly the case in the NOAA, NASA, and Department of Energy budget proposals, Santer noted. The NOAA budget proposal, for example, would eliminate the Air and Oceans Agency's research division, which includes carbon dioxide monitoring functions. In addition, the Trump administration's NASA budget proposal would cut some climate-relevant satellite missions, while stripping future NOAA satellites of climate science sensors.
I do think it's important for non-scientists to know what's at stake here. That when we lose the capability to measure and monitor how our world is changing, it makes us all less safe,
Santer said.